Okay, so when we talk about reading or writing a file from any data frame, right? So we are talking about modes, reading modes and writing modes. So when we talk about reading modes, we talk about three types of mode: permissive, drop, malformed, and fail fast. So the permissive modes is all about that, okay, if corrupted data is coming, don't worry about it. Create a new column called corrupted underscore record and put the whole record into it, right? The second thing is permissive. Okay, so default mode is permissive, and if we specify .option.mode is equal to permissive, it will behave the same way as the default mode is working. When we talk about default malformed, what it says that, okay, if we are going for drop malformed record mode, what it will do, it will drop the malformed record which is not in the proper structure. Like for example, this record we are not seeing into this result, right? And what we are, when we are going for the third mode, that is fail fast, what it will say, it won't read the data and it will fail the record as soon as Spark found a corrupted record, right? So these are the reading modes, and now let's talking about the writing modes. So when we talk about writing modes, there are four types of mode. The first is append, the second is error if exists, third is ignore, fourth is overwrite. Append, as the name suggests, it will append the data into the directory. And when I'm talking in terms of Spark, it will append files inside the directory, right? Error if exists, it means it's a default mode. What it says that if there is directory exists with the name what you the name by which you want to save the data, it will error out. Ignore means don't care about it, it won't do anything, it will just ignore the operation. Overwrite means it will overwrite the data. Okay, so these are four modes of the writing. Okay, let me go to the code quickly now. And when we see here, so what we have a test data into zip code.json. Okay, when I open this file into this directory, I'll go here, I have test data here, and I have one directory called zipcode.json. Okay, so what I did today, I have created a dummy records for you guys with some duplicate records. Okay, so it's a big file with lot of records. So let's say we are here, let's say we in between we corrupted record, right? So we are putting some absurd values. So let's say I corrupted this record, and then what I do, I will corrupt few more records somewhere, like this record, right? Control V, sorry, here, and then I'll corrupt this record as well. I'm corrupting 4 or 5 records. Okay, okay, so now I'm saving this, right? And since, let's do one thing, so let's read the file first. To read the file, what I did is spark.read format JSON, and I then give the path, and then I first of all, let's do one thing, don't drop anything. Okay, so I'll just say don't drop anything, and I'll say just here, and I load the file. So what it will do, it will create a data frame for me. Everything what I do here, I will comment everything. Okay, and let's do one thing. So I'll read the file, and what I'll do, I say zip dot count, right? So I say zip dot count. So what it will do, it will print all the records for me. Okay, so let me run it. So ideally what it is doing, it is reading the file, it is creating a data frame, and then from the data frame, I'm counting the number of lines into the data frame. Okay. So what it will show me, it will show me the number of total records into the data frame. In fact, let's do one more thing. We'll say zip.show. And meanwhile, let's create 2-3 things here with different modes. So we'll say this is your zip original, and then we'll say drip malformed, and then we'll say here zip, sorry, yeah, this is, ignore this part. So zip malformed, and then we'll say zip permissive, right? And then we will say zip underscore, and we'll say zip fail fast later. Okay, and why it's not working? Because we need to print this thing. Print this and this. Okay, so now what I'm doing here, so let's do one thing. Dot. What was the option, guys? Okay, let's do one thing here. So save mode is good. DF operations. Yeah, so option mode. Okay, dot guys. So what we are doing here, we are going, so let it be default. We are not doing anything here. And here we'll put the mode dot option underscore mode, and we'll put here drop malform. Okay, we'll copy this line, and here we will say drop. Okay, and then let's do one thing. So zip dot show, and even let's do one thing. Control C, Control V, Control V, and we will say here df dot count. That is dropped. Sorry, mf dot count, right? mf dot count and underscore per dot count, right? And let's do it now. So what I'm trying to show you here, that drop malform will all the, so I have 4 records which are dropped malform. Let's see if our, so let's go here, show view, others, console, and hit enter. And let's see how it's working. Okay. So it is creating 3 data frames for us, one with the default setting, like the default mode, one with the drop malform mode, and one with this mode. Okay, this thing is very strange. Yeah, so this thing is join, close this. Let me run it again. Something is, oh, sorry. Actually, I need to run this as Spark application because from top it was running in different mode. Okay, 1 second. So let it run in 2 minutes. So basically what was going on, so before I started this class, I was working on these 2 Scala application. So what happened when you use this default mode, right? Run Spark practical. So now since I started this, so when you see here, it is showing me run Spark practical. But before it was pointing to Spark join or join.scala. That's the issue. Okay, something happened, but what is that? Let me show you now. So let's do one thing. So first of all, it should be print ln, right? Second thing is, there's so many things which are not commented here. So let's comment them. because these are the different steps which I will show you today. And now let's run it again. So what I did, I created 3 data frames, one with no mode specified, one with malform mode, malform drop mode specified, and one with persistent mode specified, right? And then I printed the count for all 3 modes. The first count will come as normal mode without any mode, like the default one. The second one will be, yeah, so see now. So how many records were there in the permissive mode? Like without any mode, it means it will read all the records. It will read all the records. And what it will do, let's do one more thing, right? So, okay, first of all, before I do anything else, so we have total 1.5 million records, right? 1.5 million records. Or no, 156K records. So 156,160 we have total records, and I have corrupted 4 records in the beginning. So when I go for malformed count, it is showing me 4 records less. And then when I go for permissive count, like PER count, it is showing me 160 records. So it is proved that total number of records in permissive and the default one are same. Okay. Now let's do one more thing and then we'll move ahead. I'll say fail fast here. Fail fast. So what it will do? If I'm putting fail fast here, it will fail my application. It won't read it. Let's see. Okay. And meanwhile, let's go ahead and let's do one more thing. So let's see. Let's put this option here because this is how I want to work, and I will comment this. I don't want anything. Okay. So what it will do, it should fail my application. Yeah, it failed, and it gave us the same error what I shown in the one node. That okay, it was failed because of fail fast. Okay, and it's the same thing what I was showing you in the beginning. The parse mode was fail fast, and malform record detected in the schema, so our records are failed. Okay, now let me show you one more thing quickly. Yeah. So read mode done, 3 modes done. Now let's go for write modes. Okay, and let's do this part. 1 second. It's not going to comment. Control chat. Anyways. What I'm doing here now, in fact, let's do one thing. Okay, so let's do one thing. Right now, if you see my file, right? If you see my file, it has what I did to create data for you guys. I just copy pasted. In fact, before I do this thing, let me show you one more thing. So how my data is looking like. So zip.show. Okay, and let's comment this part for timing. So if I see the default data, since I have created that data for you just to make the big file from 6-7 records, I have created 150K records by copy pasting. So some rows are duplicate, and you will see this thing. Okay. So let's see. Okay. So when we see here, some IDs are duplicated. So every ID is kind of replicated, 100,000 times into my record. Let's say I don't want this repetition. I want singular ID or unique ID for the zip code. What I'll do, I'll create something, a new column. Okay, so to create a new column, right? To create a new column or to add a new column or to update the existing column, what we should use with column, right? So with column is the function what we use to add or to update an existing column, right? So let's do one thing. Let's remove this. I'll show you why I use repartition. Okay, so what I'm doing, I'm trying to update this zip code column with a unique ID, and to have the unique ID, I have used one function called monotonically increasing ID. What this will do, it will start from 0 by default, and it will increase the ID and create a primary key. So it will put something like 1, 2, 3, 4, 5, 6 in the zip code. Okay, and let's do one thing. In fact, let's do one thing here. Let's put it into zip underscore mon underscore ID is equal to this, right? And we'll say val here, and then we will say we'll copy this part and we'll simply put this Control C and Control V. So what I did here, I created a new data frame val zip mon with a new ID, and then I have written the data frame into this directory. Okay, and then what I'll do after writing it, I'll say please show me the data, how it looks like. Okay, dot show. I'll show you both. So basically zip code underscore test, right? Let's see if the directory is already there. So we'll go here and we can see here date modified. Let's say, so we'll see here test data, inside test data. Yeah, so we have test data here. Inside test data here, we have zip code underscore test, and let's remove this. Okay, so we removed it and now we run it. So what it will do for me, if the directory is there, it will create it for me. If directory is not there, it will create for me. If directory is there, it will overwrite for me, right? So right now what I did, I removed the directory and I want to write a new directory called zip code underscore test and write something, some files for me there and show me the data, right? Let's see how it works. So what I'm telling you here, that I am updating the zip code column, which has some duplicate records for the zip code, and I want to have my own records start from 0. So let's see now. So if you see here, there are duplicate records 704, 704, 9, 704 multiple time, you can see, right? Because I have created them for you guys. And now when I updated that zip code column with the monotonically increasing ID, what it did, it just updated everything which is into the zip code column and put a unique number here. So you will use with column with monotonically increasing ID to generate some random, unique number for your data frame, right? And now let's go here. And it's a new directory created for us. Inside this directory, what we have seen, by default, it created 3 files for us. Let's say we only want one file as output. Let's say we only want one file as output. What we're gonna be doing? We will do something like this. We will say dot repartition and num partition, well, we'll say 1. And when we run this again, so right now it has 3 files, and since we have the overwrite mode here, save mode is overwrite, it means everything will be overwritten and the one file will be created behind the scene. Okay. One thing which I miss a lot when I code, when you read the file, don't miss the load clause. That is, don't miss the load clause. When you write the file, don't miss the save clause. And I'll show you guys. So let it run. So if I miss the save clause, it won't give us any error, but it won't write anything for us. I'll show you now. Okay. So for now, let it be like this. Let it run for us. So it runs successfully. It reads the first data frame, that is, stupid data into and then it create a new data frame. And when we go here, it just remove everything and overwrite it with only one file. Okay, this is how it works. So now what I was telling you that, in fact, let me do first thing. So I'll just remove this directory again, and I'll run this file. And for a timing, let's say I forgot to write .save. So this is the problem here. So it won't give us any error. It won't give us any error, and it won't create directory of files for us. And it's tough to identify this kind of issue. So it's a golden rule: when you read the file, don't forget to put the load clause. When you write the file, don't forget to put the save clause at the end. So it will do everything for us, but it won't write file here. So let it run. So right now I use the repartition, but I forget to put the save clause here, right? So it is running. So it ran successfully, right? So you guys, from the log, it looks like, okay, we did a great work. But when we go to the back, nothing is created. Why? Because we forget the save clause. So guys, don't forget the save clause. Okay. So this is the most important thing. So what we did, now let's say we want to append the file. Okay. And dot append. So what it will do right now, okay, since the file is not there, so it will just create a directory for us with zip code test, and it will, because since nothing is there, so it will just create one file for us, right? Meanwhile, it's running. Let me see something else. So yeah, so now if you see here, zip code test created, and it created one more file for us. Now what I want to show you here, let me run it again. Since this is append mode, it will write one more file with 12,181 KB. Okay. And this is how append works. Append won't delete anything. Okay. And this is how it works. Okay. So we know that, okay, to create unique ID, we will use monotonically increasing ID with column, right? With column can be used to create new columns or to update the data of the existing column, right? This is how it works. We use repartitioning here just to create one file. I have told you guys. Now when we go here and refresh this, it created one more file with the same name, not with the same name, with the same size. So it is different, but it creates this because this is append mode, right? Now let's say we skip the mode. We skip the mode and we run it again. So what it will do? Now it will fail. It will say, guys, directory already exists, right? So default behavior of save mode is error if exists, default one. Okay, so it will fail out in 1 minute. So let me control that, and I will show you one more mode, that is ignore. So the last mode is ignore. So what ignore will do? So first of all, let's see whether it is failing. Yeah, it failed. And what it says, that this directory already exists. So the default one is error if exist. So the default mode is error out, and the mode for the name mode for that is error if exist. So if we put error if exist, or if we don't put any mode, by default error if exist mode is there. Now let's say ignore mode quickly. So right now, if we see here, we have multiple files created for the time 6:36 p.m. And if I run it again, if the mode is ignore, it won't even touch it. So it will run everything, but it won't write anything. Okay. So this is how it works. One more thing which I need to show you guys. And in fact, I showed it to you yesterday, that if we want to increase the number of partition, then we will go for repartitioning, and repartitioning will always go for shuffling. Why? Because repartitioning will always try to take data from all the partitions, and it will try to create the mentioned partition in the repartitioning clause, right? So this is how it works. When now coming to this again, so ignore mode, it never touched it. The timing has never changed. It didn't care about it, right? So what I'm showing you, let's say if I want to repartition data, right? If I want to repartition data, what I can do, let's say zip underscore rep underscore 8. What it means that I want to repartition my existing data frame into, let's say, 8 partitions. What I'm showing you here, so also zip dot, this is my original one, and I'll say repartition, and I want to go into 8. Okay, and what I'll do, and I'll put val here, and what I'll do now, I will copy paste this. I will write this one, remove this clause, right? Inside this test data, let's create one new directory called rap8. So it means we are doing repartitioning. And let's do one more thing. So we will, from this zip 8, let's say we want to remove this, right? So what we'll do, copy paste again this thing. So we'll say call for. So let's say we want to remove, reduce the number of partition from zip underscore 8, like this is 8 partition, right? So we want to reduce the number of partition into 4. So we have, it is confusing, but let me clear it, guys. COAL, and I'll say 4 here. I'll explain everything. Just wait for a minute. So I will copy paste this thing here, and I'll say call for. Okay, now let me explain. So what I did, first of all, we have the existing data frame, right? And what I did, I created a new data frame, reading data from the existing data frame, and I've divided that data frame into 8 partitions. Okay, and then I have written that data frame into a directory called rap8. Then what I did, from this data frame zip underscore rap underscore 8, which has 8 partition, I used the data frame and I reduced the partition into number of 4. So to reduce the partitions, we will use coalesce. To increase the partition, we will use repartitioning. Okay, and then I return that partition into call for. Okay, let's do one thing. In the mode here, quickly, let's say we want to append or something. I don't want to go for default mode. I just want to go for anything else. Okay, and let's run it. So ideally what it should do now, it should create 3 directories. One directory is already there. So it should create 2 more directories, zip code underscore rap8 and zip code underscore call for. Rap8 means repartitioning to the 8 partitions. Call for means reducing 8 partition to the 4 partitions using coalesce. Okay. So let's go here in the test data. We have nothing here, only zip code, which we have created in the previous one. And it should create new directories here for us. So it is running, and when we go here, so it's created zip 8 here, right? It has created zip 8 here, and it had created call for here. So we have 2 new directories created: zip code rap8 and call for. Let's go inside. So what we have seen here, that inside this we have 8 new files inside rap8. It means we have partitioned the existing data into 8 files or 8 partition, and then we write it. So it returned the whole data into 8 partition. One interesting thing to see here, most of the partitions are equal size except 1, 2, right? Only 1 KB difference. Why they are equal size? Because what repartitioning do, read the data from existing partitions and try to create equal size partitions. We don't know inside, maybe inside this partition, the data can be of any zip code or anything. We don't know the data, but when we go for the size, the file size will be equal, right? Now let's go here in the call. The call also almost equal size, but what coalesce tried to did, what coalesce did, coalesce try to did this thing. So what we did, we have created 8 partitions, right? So 1, 2, 3, 4, 5, 6, 7, and 8. So we have zip file, and from the zip file, we have created 8 partitions using repartitioning clause, repartition 8, right? From this repartition clause or this repartition, we use coalesce, and we say 4. So it did 4 partitions. Okay, how repartitioning work? Obviously, it read the full data. Let's say this data is split across 3 partitions. Let's say, I'm just assuming 1, 2, 3. What repartitioning did? It read all the data, put that into, I'm just assuming, right? Put that into one particular folder and created equal size folders from this. And that's where it will be a full reshuffling operation. So the shuffle will be there for sure. So the repartitioning will be surely causing the shuffling. Shuffling means transferring data from here to here. But now, if we reduce the 8 partition into 4 partition, what it will do? Let's say these 2 partitions are on the same data node or same executor. These 2 partition on the same executor. These 2 partition on the same executor. In fact, let's do like this. So let's say these 4 partitions are on the same. So we have 3 executors, E1, E2, and E3. What coalesce will be doing? It will combine, it will try to prevent shuffling. So what it will do? It will try to merge the same partition, let's say P1 and P2, and merge them and create this one. P3 and P4, it will merge them on the same data node without causing shuffling and create this one. It will merge these 2 and create this one, and will merge these 2. So what coalesce will try to do, if data is there on the same data node or on the same executor or on the same worker, it will try to merge them inside and reduce the number of partition without causing the shuffling. This is how coalesce works, okay? And due to which coalesce won't give you the guarantee that the number of partition, size of the partition will be always equal. Maybe the partition size here is 4 MB, and here is 3 MB, here is 2 MB, 2 MB. So what it will do? This partition will be of 7 MB. This partition will be 4 MB, because the main purpose is to reduce the number of partition, preventing shuffling, right? This is how it works. So this is, we have proven that, okay, coalesce will give us the less partition and it will prevent shuffling and all. Now let's try to do one more thing. Yeah. So yesterday I was telling you about Spark functions, right? How Spark UDF works, right? So let's say, now let me comment this part first. I don't want to do this thing. Let's remove everything, okay? Let's go till here. So we are commenting this part, and let's jump to what we say, UDFs. Okay, so prove the UDFs. Let me uncomment this portion. Let me explain what I'm doing. So first of all, we have a data like this. Okay, so I have created a new data frame. Okay, so to create a new data frame, there are multiple ways to do it, but the easiest way is to create a sequence or list and to pass it inside create data frame function. So what create data frame function will do for you, it will create a data frame with the data which is given to it into list or sequence format, and then we need to give some structure to it, right? Give some names to it. So what we did, in fact, let me put it in 2 lines. Let's go like this. So we have this sequence, right? So what I did, I have created one sequence with some names. I have put some country names, US, USA, United States, whatever. And then what I did, I have 4 columns, 1, 2, 3, 4, and then I give name to those columns using 2 DataFrame. So if I put it into like this, so first it is for testing. If you want to create a data frame for testing, create a list or sequence, right? Second, pass it to create data frame function, right? And then use 2df to give the structure to it. So we can give names here, right? Column names like this. So what I did here, I created one sequence, I passed it under create data frame, and then I have used 2df at the end. Okay, so let me put in the same line, and let me show you guys first how it is looking like. So to see the data, it's simple. Well, in fact, just copy paste, Control C and Control V. Dot show. Okay, so what I'm doing here, what I'm planning to do here, I want to see whether this country name is correct or not, right? For us, it's very simple. US is a valid country. US is a valid country with small a. This is valid. United States of America is valid. But this one is not a valid country. USSAA, right? And United States is a good country as well. Like it's a valid name. What I want to know, I want to create a function which will render through all these, right? And it will give us whether country name is valid or not, right? So what I did, I created a sequence or list again in which I have the name of all the valid country, US, USA, whatever it is, right? And then I created a data frame again. So I created this sequence again, and then I created one function. It's a very simple function. What I did, the function name is clean country. It will accept one country as a string, right? And then we are passing a sequence of this, and then what we say that if the string what we are passing into this function, if the string what we are passing into this function is a name from this list, then return USA. If the name is not in this list, return unknown. Simple, right? So how it will work? So let's say this all USA is a function name, okay? So we pass, let's say, in fact, let me comment it just to show you guys. So if we pass USA, it will return USA, right? If we pass USA, it will again return USA. But if we pass this one, it will return unknown. Simple. This is how it functions. This is how this function is working. Okay. So now this function is created, right? Now the thing is how to register this function into Spark so that it can be used without any difficulty, without any references to this original function anywhere into the Spark context. Okay, so what we need to do, give any name, whatever we know, whatever name we want to use. For example, the original function name is clean country, right? But I want to use the name normalized country, right? And inside this normalized country, I want to give the function, like which function I'm registering, clean country, on by which name I need to register normalized country, right? This is how it works. So once this function is registered, so this is the way to register the function, spark.udf.register, and then you need to say this one. And now we want to see, right, whether the country is correct or not. So what we will be doing, we will be using with column clause. With column is used to add a new column or to update the existing column. So in this case, we are adding a new column. Name of the column is normalized country, but what the value of that column is, we are using our function, right? We are using our function name normalized country, and we are passing the country column into it. Let me do one thing here. So we'll show two things, user data dot print schema. So this is what. So I'm passing the country column from my user data frame. What is my user data frame? This one. And I'm passing the country column, and it will give me USA or unknown. Let's see how it's working. Okay. So this is how you need to use UDFs. You can create any UDF and you can use that UDF onto any column, but you need to register it using Spark UDF register. Okay. So this is the one way to register the UDF. There is one more way. Let's see that as well in 2 minutes. So let me start from the beginning. So our data has 4 columns: ID, name, city, and country, right? The data looks like this. Let's focus on the country column: US, USA, United States, and this is the wrong column, right? Then we write our function to validate the country name, and then we use the with column clause. We use the with column clause to add a new column called normalized country. And then inside this column, we used our function called normalized country function, that is this one. And we pass this country column inside that function to validate the value of that country column, right? So it worked like a charm. So for all things, it converted it into USA, but the 4th row, which has the value USSAA, it says unknown country, right? One more important thing, which is important, how to write this, right? So when you use normalize or any UDF and you want to pass a value inside the UDF, you need to say like this. So your UDF name. So one second, your UDF name, right? Inside that UDF name, you need to give your DF name, data frame name, right? And then inside this DF name, you need to select a column. So select a column, you need to use call clause. And now you need to give the column name. So it will be call underscore name. So this is how it works. Let me explain it to you because this is important and people will get confused here. So into our case, what is the UDF? What was the UDF name? UDF name was normalized country. DF name was user data. Then we use the call clause and then we call the country column, right? And again, I'm telling you, we use Spark UDF, spark.udf.register to register the name. We give a name and we give the original function name. Okay. This is good. Now let's see one more thing. Okay, let's do one more thing, right? So I have explained it to you that, okay, in the zip code file, I have created so many duplicates, right? I have created so many duplicates just to replicate the data so that we have more amount of data. But let's say I did that duplication by mistake, and now my manager asked me to reduce all the duplicate rows. So we know one thing, that this file has so many duplicate records. Now, if my manager asks me to remove all the duplicates, what I will be doing, I will say something like this, that zip8, I'm just doing it, okay, in this way. Yeah, let me use the code, what I have used here, mf.read, where's my right code? I want to reuse that code. Yeah, so let's say I want to use this code, okay, and I want to say a duplicate function here. So I'll say I'll create a new RDD, let's say remove duplicate. Okay, I don't want the duplicate here, so I'll use the new RDD name, remove duplicate, and I will say drop dot. So which function I need to use? Drop duplicate, this one. So what this will do, it will create a new RDD and it will drop all the duplicates. And let's say, if I just simply say Control-Y, and if I simply say Control-V dot show. Okay, so in fact, let me do 2 things here. Zip dot show and zip remove duplicate dot show, right? Zip dot show has duplicate, zip dot remove duplicate will not have duplicates. Let's run it. So drop duplicate is the function which we use to drop all the duplicate rows from the data frame. Okay. Okay. So here, yeah. So if we clearly see here that it has duplicate 704, 704 something, and when we come here, it has no duplicates. So it has no duplicates here. So although you are seeing multiple times zip code, but these rows are not duplicate, right? It has different rows. So this 704 has Pasio, Costa, Del Sur, it has something else. But when we go here, it has duplicate rows. For example, yeah, but this is how it works. Okay. So the duplicate record. Now let's say into this case, let me comment this part for a time being. And I want to uncomment this part in which we are playing with the functions. Okay. So let's from here and till here, I want to uncomment this. That's not working, uncommenting. One second. Basically, it should work anyways. So if I select this part only, I'll say, okay, 1 by 1 is working. Okay, no worries. I'll say 1 by 1. So I've created the data frame. I have this one. I have added the data. I have added this, and everything's good. Now let's run it quickly. Okay, so what this function was doing for us, it is creating a new column called normalized country, right? And it is having extra column with country. Now let's say, and let it come, but let's say we want to remove this country column. We want to remove this country column before we use the data, or we want to have only one column country, right? So when we go here, it will have two countries column, one with normalized country and one with original country name. Let's say we don't want to have this country column. What will say? Dot drop, and we will say we don't want country column. So if we see here, we have two columns coming, right? Country column and normalized country. Ideally, there should be in this country column we don't want this country column. So what we say, drop column country, and then we'll say dot show, right? Because obviously it doesn't make sense. Either this is valid or this is valid. So for us, normalized country is the valid column. So we'll say drop, we'll use the drop clause, and we'll say dot show. So it will drop the columns for us. Okay. This is good. So we know how to register a data frame. We know how to use the data, register a Spark function. We know how to register it, how to use that Spark function. Now, let's say, let it come, then I'll show you something else. Okay, so now the country column is gone. It has only one column, normalized country, and that makes sense to us. Okay, so let's say we want to select only few columns. That's very easy, right? And we have done it in past, but let's do here. So let's do one thing. Let's put this into a data frame. Let's say, well, normalize country. Okay. And now see one more important thing, and that's a mistake what a lot of people do. When we go here, what is this? This is a unit, right? Why it's a unit? Because we have a show clause in the end. So if we remove this show clause, if we remove that show clause, now it will become a data frame. Perfect, right? This is also the one of the mistake what people do a lot. So if you want to create a data frame from another data frame, please remove the show clause, then only it will convert to the data frame. Now let's say we want to select few columns, let's say name and city only. So what we'll do from this thing, what does it say? Dot select, and then we will say, let's say we want to only want to select name, just for time, and we'll say dot show. So basically what I'm trying to show you here, that to select the columns from the data frame, there are three ways, right? So the first way is this, we will use, this is called string form to select the column. The second way is to put, okay, let it come, but to put the call clause. So this is called the column object form to select the column. So let it come, so it will give us only the name, right? And I have used one more function, so I'll put it here. In fact, I have made the notes. DF operations. Yeah, so there are three ways to select the column. The first way of select the column using the call string. So this is how it will work. You need to put the column into double quotes, and you need to give the column name. That's all, right? So it will work. So it worked like this. So now the second way is to, this is the first way. This was the first way, right? The second way is using the call clause, column object clause, and the third way is this one. So you'll just give dollar here, dollar, and call name. Okay, dollar, just one second. Dollar dot. Anyways, I'll have a look. Okay, but these are the two ways. Let me run it, so it will give us the same result. Okay. One more important thing, which I want to prove it here, that you cannot do this. Let's say if I select this again, and if I say select call and then ID, what it will show me that, guys, something is getting overloaded, and this method of select is not defined in a way that you can use call object and call string in the same select. So either you need to put call here like this, and the error will be gone. So error is gone, right? So, or remove the call from both the objects. Okay, so call strings and call object cannot be mixed and matched, because select function is not defined to have both call string and call objects to be in the same clause. Okay, this is important. One more thing is, let's say, and let's do one thing. So if I want to select everything, right? So there's what we can say, select star like this, and let's run it. So it will give us everything, right? Select star means it is same like SQL. It will give us everything. Okay, and let's say if we want to mix, if we want to concat, let's say city name and the country name. Okay, so if you want to concat city name and country name, it means these two columns. We want to concat these two columns. So what we're gonna be doing? So first of all, the select star is still working, but let's say if I want to concat this one, select star gave us everything, right? Now let's say if I want to select these two columns, but I want to concat them. So what I'll say, select concat inside this, right? And let's put column here, and it is saying that type mismatch string this, whatever. And so just give me a second. I have used, okay, 1 second. So what it is saying that concat won't work with string clause. You need to use call clause. So we'll say call and call, and here also call and call. So any function if you want to use, right? You will always go for call clause. Let's say this is good, and now let's say if I want to give this some alias, so I'll say dot alias, and we will give a name. Let's say country, CNT, and city, and we'll say like this. Okay, so it will give us everything in the concatenated way. So it will say city and country are concatenated, and it will give it to us, right? One more important thing which I want to prove here, that, so let it come, but let's say we want to store the data. I'm commenting it for a time being. So what it's showing here, 1 second, cannot resolve country. Yeah, it won't resolve country, I know, because country column is not there. So basically we need to put here this one, right? And it will work because I removed the country column. So to use the concat, you need to use call column. That was I was trying to prove. But since I removed the country column, right? What I did here, I removed the country column, this one here, and I tried to use it, so it gave us this error, right? But that's not, so basically I won't be running it again, but this is how it works. One more thing, let's prove one more thing here. So we have zip data with lot of duplicate rows with just what I created, right? Now let's see one thing. So we created this new zip file with monotonically increasing ID. Now let's say we want to save this data, right? We want to save this data like this, and while saving it, we want to put that data into buckets. In fact, this is not the correct example. Let's go here. So what we want to do here, that we have orders data, right? So I'm going to another file. So what I did here, I read the orders file. Now let's say if I want to partition, if I want to partition the orders file into number of partition based on the order status, right? So what I'll do, I will do something like this. So what I'll do, I'll say orders.write and partition by clause, and write the partition in CSV format, and if there is some file there, overwrite it, and partition by, let's say, order underscore status. This is the new column. This is the new file. Okay. So let's say, and we want to comment this because this is the next topic which we'll cover, and we'll run it. So what it will do for me ideally, and let me go here and let me show you some data. So if we go here, this is my Cloudera VM, right? So if we say use retail DB, and then select basically I want to show this thing as well. So orders and distinct order underscore status from orders and limit 1, remove this. So what we see here, we have 9 rows came, right? So how many rows are there? 9, right? If you're not seeing it, let me. So there are 9 rows. Okay, I'm not sure whether this is visible, but there are 9 rows. Okay, so now we run this. We pulled, like what I did today. I kind of copied this data from this virtual machine into my local, and I'll show you the process. But what I'm planning to show you here, that since I partition my data using order status, it should create 9 different directories inside this. So let's go here. So it's something for us, and let's go into output part by order status. So let's go here inside this directory. This directory we have output, and let's go here inside output. We have part by order status. 1 second. Partition by order status, format this dot mode. Just 1 second. Let's see. It's not working. So orders dot write dot partition by order status. Let's do one thing. Before we do this, let's say here orders dot show. Okay, and let's run it. Oh, sorry. What I know what's going on. So I ran from here, right? So again, I did the same mistake. So what it is doing, it is still running Spark Practical. So whenever you are switching these tabs, right? 1, 2, I have opened 5 tabs. And if I want to switch the tab, always on the safe side, always run this. Run as Spark application. And now if we go here, it will say joining. This is joining file name, and it will say run joining, right? So that's the mistake I did. Anyways, so it will run. So this is the best practices, just go for this option most of the time. Don't be lazy like me. Just go for this application, okay? So now when we go to the output one, it should create a new directory here with the name part by order status. Let's see. Okay, makes sense. And it created a new directory, part by order status. How many orders status, distinct order status were there? 9. Let's go here. How many directories are there? 9. Inside cancelled, we have cancelled order. Inside closed, we have closed order. This is how your partitioning works, right? So partitioning, one more important thing. All the partitions cannot be of equal sizes. We cannot guarantee that, right? And one more thing, let's say if you want to bucket this data, and we'll say bucket this data into 4 buckets based on, let's say, order underscore ID, right? So there's one column called order underscore ID, right? And we'll say something like this. This won't work. Why? Because by default, bucket is not supported by save, right? Let it run, and then we this will again to resolve this, we have some other options, but let's see. So it will fail for sure. So let's do one thing while it's failing. So I will remove this clause for a timing because I will prove it later. So I'll put it here. So it will fail. What it says, it simply says save does not support bucket by operation. But how to put the bucket operation? We'll say save as table, and then we'll say some table name, right? So we'll say table name here, let's say tab, one second, table table, and we'll say orders underscore bucketed, something like this. And what it is showing me, okay, it is saying something else. Let's Control X, and let's say dot save as table, and then we'll say bucketed orders. Okay, something bucket underscore orders, right? Let's say one more thing. We'll remove this because I was practicing it. I'll explain it to you. So we'll say remove it, and we'll remove this as well, and we'll remove this as well. Anyways, okay, so I have removed a few files, and let me run it again. Okay, so ideally what it will do, it will create a table for me. Okay, and now when we talk about tables, right? So table has some structure, and table has some metadata store, right? So what table means? Table means a file which has some structure attached to it. The structure is called metadata, and metadata will be stored somewhere. This is how your table creation works in any system, right? So there will be some data, the structure attached to it, and then the structure will be stored somewhere. So something like this. So you have your table, you have your file. So this is your file, which is comma separated. You put a structure over this file, ID, name, something, and you store this structure into some Metastore, and you stored this file into HDFS, something like this on the overall. So you stored this Metastore, right? So what it did, it creates something for us. And when I refresh it, so we are not seeing any Spark directory here, Spark data warehouse directory here. So if I refresh it, right, it created a new directory called the Spark warehouse directory, right? And so let's see here. Oh, sorry. One more mistake which I did here. Save as table, obviously, see, these are the things which people learn from mistake. So save as table and path won't work together, although it will not give you any error, but they like, for example, I run this, right? I run this command, it runs successfully without any error, but it created a Spark warehouse directory for me, but it didn't create a table for me, right? So why it didn't create any table? Because this clause was before that. So I remove this clause and I run it again. So what it will do, inside this warehouse directory, it will create a new table, bucketed orders, in which it will have 9 directories with the order status, and each directory will have some files into it. Okay, let's see. So now let it run. So meanwhile, let's refresh it. Okay, it ran successfully this time. And let's go here and let's refresh it. Yeah, so this time when we refresh it, it came here. So we have a table called bucketed orders, right? Bucket orders here. When we open the bucket orders, it has some temporary directory. Inside temporary, it has temporary. Okay, maybe it's running. Anyways, not sure why it worked like this, but it has 1, 2, 3. Let me refresh it again. Maybe it's writing. So 1 second, guys. Okay, when I opened it, it was still running, although the process completes here. So it has 9 directories now. Inside each directory, we have 4 files. Inside each directory, we have 4 files. How it's working? So it first created the partitions. So it means partition means it created the 9 directories based on each order status. Inside this partition, it create 4 buckets. Buckets means files, right? So partition means directory, bucket means files. I've already explained it in a lot of detail, but again, I'm explaining it to you since it is very easy to prove here. So when we say order status, what it did, it created order status, cancelled, and then it in all the cancelled order have been further divided into 4 files based on order ID. By default, it will use the hash function and it will divide the data in 4 partitions. Let's do one thing. Let's go here. And let's see one thing. So workspace, and where I was, Scala practice, right? Here. So see now, bucketed orders. Now what I want to prove here, all the files are of almost equal sizes, right? And this is how bucketing works. So bucketing will give you the data for like it will divide the data based on the order ID and it will put everything. So yeah, so it may or may not be of the equal sizes. Okay, so this is good. So this is how bucketing works. Now, one drawback of this approach is saveAsTable approach is that once we close the session, this warehouse directory, everything will be gone. It won't be persisted, right? Because everything what I'm doing here is onto this machine, onto this session, right? And you know, in Hive, right, we have a Metastore stored into MySQL database, and whenever we close the session, still the metadata is safe. So how to do that kind of functionality here? How to make sure that this data is stored into some Metastore? So right now, if you see, this data is not stored into Metastore. This data, this Metas data is not stored into some metadata. So what we need to do that, so what we need to put into our Spark session, this one. Say Hive enable support, right? Enable Hive support. And when we run it again, what it will do, it will, and basically I have run it in the previous session, it will create a new directory called metastore_db. Inside this directory, it will give us everything for the metadata. Obviously, it won't make sense to us, but it will give everything. So this is the best practices for storing the metadata in the persisted way. Okay. So it will run in 2 minutes, but let me cover one more thing. I know this session is quite lengthy, but we have many things to cover. So let's jump to joins as well. So obviously, when we work with different disparate data sources, so it means we need to join them sometimes. So now see what are different type of joins available in our Spark data frames. So ideally, in any SQL type, or there are basically 4 types of join. There can be a number of joins, but these are the 4 most important joins, right? So we'll call them left join, right join, inner join, and full join. And let go one to one. We'll start with inner join. So let's say you have 2 data sources, first data sources and second data sources. What inner join says, give us everything which is common across both the data sources. Give us everything which is common across both the data sources. For example, let's say if I have 2 tables and I have one column called order ID here, other table has customer order ID, and I have 1, 2, 3 here, and I have 4, 5, 3 here. In case of inner join, this row will match to this row and the result will come like this. I'll show you. In case of right join, what it says, give me everything which is of the right table, right? And which is common to both the tables. In the left join, it says, give me everything of the left table and which is common to both the tables. In full outer, it says, give me everything, whether it's common or not common. Let's see it quickly. So I have taken this example from a site called what it says. Okay, I think I have added the Hive Metastore in between, so it failed. But let's ignore this. So I have copied this example from the site called sparkbyexample.com. It's a very good site. Okay, and let's do one thing. Let's comment everything, uncomment everything. So what this guy is doing, one second. Not sure why my machine is not uncommenting everything at a go. Let's do quickly this. Control Z. So okay, let me run it and then I'll explain it to you in a lot of details. Okay, let me run this application. So again, I was doing the same mistake, but I need to run it from here. So what I'm doing here, that I'm creating a data frame with employee, like, right? And in that employee, I have few columns: employee ID, name, superior employee ID, year joined, employee department ID, gender and salary, right? And then what I'm doing, that I am converting that into data frame and using this employee columns to give the structure to it. Okay, and then I'm creating one more data frame with only two columns: department name and department ID. And again, I'm converting them into data frame using this particular string, right, or sequence. Now let's go one by one. Okay, before I jump, how join work in Spark. Okay, so join work like this. So you need to give the first data frame name, then use the join operator, something like this. Let me write it for you guys. So we'll say empdf, when you say dot join, and we'll go here. So you need to give the right data frame name, right? The left data frame, then the right data frame. Let's say I go for department df, right? And then what we need to give here, we need to give on which column we need to join the data sources, right? So let's say I'm just copying it and I explain it to you. I'll say this one. So what I'm showing you here, that join on employee df, from employee df use employee department ID, from department df use department ID. And to compare this into Spark, you need to use 3 equal to signs. By default, if I'm not giving it anything, and the last thing what I need to give is the type of join what I need to have. Let's say inner. But if I skip it, if I don't give it, by default it's inner for sure, by default. Okay, this is how it works, right? So, and then let's go here and it will say dot false. Okay, so now this is how it works, right? So let me explain it to you. So first we have inner join and it will show you everything. Okay, so this is our department table, sorry, employee table. In employee table we have six employees, and into this table we have department ID 10, 20, 10, 10, 40, 50. Into department table we have 4 rows, 10, 20, 30, 40. But we, in the employee table, we have one orphan department row with the 50. When we go for the inner join, ideally it will give us everything which is common across both the tables. So it means 50 should be skipped. Let's see here in the inner join, the 50 department row is gone, right? In the outer join means full outer. It means give us everything from both the data sets. Now, one more important thing, when we are joining both the data sources, this row, what is the department name for this row? When we go to department table, okay, 50 is not there. But when we're joining, what SQL or Spark will do for us, it will put for these two columns null. Why? Because I don't know, and we are asking it to, give us both the rows. So when we go for outer join, so for these rows, right, it gave us everything. Okay, one more thing. So for this row, it gave us everything, but for department number 50, it only gave us null. Like department name, department, because don't know. One more thing is 10, 20, 30. Okay, so it has two departments, right? So it has, okay, so 50 department is not in the department name. So it means it is orphan department. But with the 30 department, it has no employee ID attached to the sales. So it means in sales, nobody is working, and we don't know what 50 department is. Department of 50 is, right? So what it did, when we combine in the inner rows, it only gave what is combined. So you can see here nobody is from sales, and 50 number department is not there because we don't know which department is this. In the outer join, what it did, it gave us everything, department of 50 and department number 30. Department number 50, we don't know what the department name is, but it put null towards it. In department number 30 in sales, it don't know which employees are working for this department. So what it did, it put null there. So this is how outer will work. So, and even most of the left outer, right outer join works like this. So if it don't know the data which is it matching, it will put null there, right? So into our Spark outer and full outer. So when we go here into our code, so the outer and full outer are same thing. So you can use anything from these keywords, right? So full outer, full and outer are almost same. Almost mean equivalent to each other. Similarly, right outer are same. So let's see how right join works. So what is our right table? Our right table was employee. So what right join says, give me everything from the right table. Give me everything from the right table, even though the matching record are not there in the left table, right? So what is our right table? Our right table was employee. So into our employee table, how many employees we have? We have 6 employees, right? So into our employee table, we have 6 employees, right? 1, 2, 3, 4, 5, 6. And when we join this with the right, so what it says, give me everything from the right. So it means give me 6 records from the right. And for the matching records, don't give me everything. Okay. So let's see here quickly. So what it gave? It gave us 1, 2, 3, 4, 5, because 5 records were matching. 5 records were matching. The 6th record was not matching because department ID was not there. But since it is right outer, Spark or SQL needs to pull this record from the right table. So it will pull everything from the right table. So what it did, it pulled everything from the right table and it inserted null for the data which it don't know. Okay, so let's go to the code again and how it works. So this is your right join, right? So what we say in the right join, guys, employee DF is my right table, department DF is my right left table. So give me everything from the employee DF. If results are not matching, so give me everything which is matching first thing. If results are not matching from the left table, put null into the left table columns. Put null into the left table columns. Okay. So this is how it works. In the left join, it works like this. So just one second. Yeah. So let me explain once more. In the right table, how it works. So give me everything. So how right works, right? So in this is our left. Employee DF is the left table. Department DF is the right table, right? So what right join says now, give me everything from the department table. Give me everything from the department table. How many rows we have in department table? we have 4 rows. So what it says, give me everything from the department table which is matching from the employee table. The rows which are not matching, still give me those records, but put null there. So 10, 20, 30. So basically, if we see both records, let me explain it to you in details now because this is important. So we have 10 here, 10 is matching, 20 here, 20 is matching, again 10 matching, 10 matching, 40 matching, 50 not matching, right? And 30 is nowhere here. 30 is nowhere here. So what it says, give me everything which is matching. So 10, 20, and 40. So first record, second record, third record, fourth record, and fifth record. They should come ideally. So what it will do, it will pull everything, these 5 records, because these 4 are matching. And since this is right outer and our right table is this, it will give this as well. But for the left table, since it don't know what is equivalent to IT, it won't put anything. Okay. Okay, for sales actually. Sales, it won't know anything, so it will put null. So let's go here into the right again. Now it will make sense to you guys. So what we see here, for 10, it gave us 3 rows, right? For 20, it gave us 1 row. For 40, it gave us 1 row. For 30, it gave us 1 row, but since nobody is working, it returned the employee details as null. So when we jump here, this is how the write work. So write, what it did, so into write, it gave us everything. It gave us everything which is common, that's the first thing, and everything which is into the right table. Into our case, 30 and sales is not matching, right? With the left, is not matching with the left, but still it gave us 30 and sales and put null for the left table. This is how it works. In other way around, the left will work. So how left is working? Left gave us everything, 6 records here, but for the department number 50, that is sales, it gave us null, right? So this is how it works. One more important join is left empty. Left empty means, guys, give me, so for example, you have 2 tables and you want to find the records which are not matching. Matching finding is very easy, but we want to see which are not matching. So we'll go for left empty, and it will give us the record which is not matching in the left table. So into our case, this record is not matching, right? So I'll share this code with you, but this is how it works. Okay. So how Spark join works? You need to give the first DF, that is your left DF, then you need to use the join operation, then you need to give the right DF, then you need to give the condition on which you want to join the data frames using triple equal to operator. And this option is optional. By default, it is inner, but if you want to give right, left outer, full outer, whatever, you need to put in double quotes here at the last, right? This is interesting. And now one last thing. So let's say you have orders table, customer tables, and order item tables, right? And you want to join 3 tables. You want to join 3 tables. How we will do it? It's very simple. So first of all, we will go for orders, join customers, right? On which column we need to store, join, let's say this one, customer ID. Then we want to join the resultant data set or data frame with order item. So we'll say the join operator again. And on which column we need to join again? Orders, order ID, triple equal to order items, order ID. This is how you can join multiple data frames in a single operation, right? This is how the multiple join conditions work. So I think this is and for today. It's a very lengthy session, and I wanted to cover everything. So tomorrow we're going to be covering Spark SQL. But do go through this session. It's very important, and let's meet tomorrow.